Okay. All right, we're going to get started. So I'm just going to walk through our outline of what we're going to be covering today. So Archita is going to get us started talking a little bit about the SAS Intel partnership. Mark alluded to the evolution that we are starting to see. So I'm going to kind of introduce that concept, the evolution that is happening from models to agentic systems. And then Archita is going to come and talk about why infrastructure has become so important, thinking about this evolution. Then if you have actually talked to me in the last couple of days or in the last year, you probably have heard me talk about SAS Retrieval Agent Manager or SAS RAM. So I'm going to be using that as an example to talk about what an agentic pipeline looks like. And then Archita will come and continue the conversation around infrastructure and why it's so important, focusing on the optimization between CPU and GPUs. And then we'll round it up with some key takeaways. So with that, Archita, you want to get us started?
Thank you, Saurabh. Hello, everyone. First of all, before we start talking about the agentic AI and SAS, the RAM and all that, I would love to tell you why, first of all, Intel and SAS is working together. So as we all know, in the current world, there is a huge demand for analytics and compute. And with the growing data need and the complexity, there is a need for performance and improvement. And with all that, everybody is looking for a cost-effective and more efficient solution, and that is what we together are trying to build with SAS analytics and Intel hardware, optimized SAS analytics on Intel hardware. And that is what we are trying to deliver with the enhanced productivity and high performance analytics with, of course, the advanced AI capability that SAS software is offering on Intel hardware. So that's it. Let me tell you more about exactly what we are doing as far as the latest infrastructure is concerned. So Intel has come up with this new chip, which is called Xeon 6. And Xeon 6 has AI accelerator capacity and all that. So with all that, SAS software has been optimized on Intel hardware. And by the way, it is available on all major CSPs, GCP, AWS, and Azure coming soon. And of course, it is available on on-prem, Red Hat, and beyond. And as far as the SAS software optimization is concerned on Intel hardware, as you can see from the graph, the performance as well as it is a huge, there is a TCO advantage on the SAS analytics on Intel hardware. And of course, I'm not going to go too much into detail, but that being said, I will go to the next slide and hand it over to Saurabh to talk about it further.
Thank you, Archita. So before I dive into my content, I wanted to just step back and talk about this quote from Roy Amara. It's also known as Amara's law, that we tend to overestimate the effect of technology in the short run and underestimate the effect in the long run. And if you think about it, it's quite applicable to AI, the field that we are in right now. So I just thought that would be a very applicable quote to get us started here. So with that, let me just dive into my content. So I started with the introduction of this evolution that we're starting to see. So the idea is that when we think about AI, we think about interacting with LLMs. You have a prompt, you ask the LLM a question, you get a response. So we're starting to see an evolution for sure. And this evolution is not just from models to agents. The idea is that we are evolving from isolated intelligence to systems that can act, right? That is the promise of agentic AI. And to actually achieve that, you need to do a far more different things than asking LLM a question. You may be actually doing data management. So think about unstructured data. You need to extract text from this. That's where OCR could come in. You may need to vectorize that so that you can enable retrieval using semantic search on it. LLM is still in the mix, obviously, the general purpose intelligence layer that's powering this. That's providing the reasoning layer. And then for these agents to become useful, they need to connect to tools. So you need to be doing that. These tools drive actions, which is ultimately what's delivering the outcomes that enterprises are looking forward. So that's the evolution that we are in. And what is really interesting to note here is that when you start to kind of break this down, each of these steps is heterogeneous, and it has its own characteristics in terms of compute, and that calls for a very deliberate infrastructure strategy. So let's take a look at that. So if I look on the left side of it, I've tried to kind of break this multi-step pipeline down, looking at individual workload characteristics So if you look at the top part of it, we're talking about some text extraction, which is where these are CPU-friendly steps, highly parallelizable, high throughput. Once you start to convert the text into vector embeddings, that can be done in batch. Again, throughput heavy, but quite CPU-friendly. Once you have the embeddings ready, then you get to the retrieval step. This is where latency becomes really important. It is memory bound. LLM reasoning still remains the core element of it. That's the general purpose reasoning layer. It is compute intensive, could be bursty depending on workload requirements. And then you get to the tools and the integration aspects of it, which is IO bound, orchestration heavy. So it's really important to look at this as a multi-step pipeline, look at individual characteristics of these steps to think about the infrastructure. But you're also dealing with some overarching goals. As with any enterprise setting, you're thinking about cost effectiveness, how do I scale from here? Security and governance have to be at the core element of it. And you need to have this infrastructure ready to go when you need it. So availability and procurement become really, really important. With that, I pass it back to Archita to talk about why infrastructure is so important in this context.
So first of all, as you all know, when Gen AI came in, it was all about model-centric, and everybody thought that the AI, GPU is a synonym for AI. But nowadays, with the advancement of AI, everybody has started realizing when AI is moving from model to the system-level optimization in terms of like agentic AI and physical AI and whatnot. And that's where everybody has started thinking about, like, not all workloads are GPU-centric. Not all workloads require GPUs. There are so many workloads like OCR, embedding, retrieval, re-ranking, many types of inferencing, for example, small language models, or even the bigger models which requires less active parameters, or even MOEs and stuff like that, which does not require a GPU. You can still work with the CPU and get the results and efficiency and performance that you are looking for, right? So that is where Intel hardware comes into the picture, and that is where the beauty of SAS and Intel working along comes into picture with the RAM. And that is what we are working together to achieve the on Intel Xeon with higher throughput and memory bandwidth and the flexibility. You can achieve with a CPU a lot of things, along with, when required, of course, GPU, but many things using CPU by itself. That being said, let me tell you more about our latest Xeon 6 processor. Of course, I'm not going to go too much into details, but just want to emphasize that it has many cores. As you can see here, it is mentioned 128 cores, much more bandwidth and cache, as well as it has built-in AI accelerators like AMX and AVX512, which can help you with the AI workload. Of course, if you have more questions about the same, please feel free to stop by at the booth. We can give you more details around the same. That said, moving along, I will leave it up to Saurabh to take you further.
All right, so let's now put an application lens on top of it. So SAS Retrieval Agent Manager, or RAM, is our recently launched product. It supports agent lifecycle management. It has full support for retrieval, tool development, agent development, multi-agent orchestration. So when we start to kind of break open an agentic pipeline from a RAM lens, this is what it looks like. So on the top layer, you have agents. And these agents are what's orchestrating the workflows. So within RAM, we can do single agents. We can do multi-agent workflows. We have the capability to isolate agents, so they can be deployed in their own containers. And once you do that, you're able to associate specific limits to these agents. So that's at the top. If you start to look at the bottom layer, the LLM inferencing is what's driving the reasoning here. So as Archita was talking about, when you think about LLMs, you think about GPUs. But that's not necessarily always the case. So within RAM, we're agnostic to the language model. So we could actually have a spectrum of models. Some of them could be large, some of them could be small. And when you're thinking about smaller, specialized models, you could actually get a pretty good level of performance from CPUs, right? So that's an area that we're focusing on with Intel. Then on the bottom left, talking about the retrieval layer, that's a really important part of our pipeline. So our retrieval depends on embedding models that are optimized for Intel hardware. So we use ONNX as a format, and when run on Intel CPUs using the OpenVINO framework, we see tremendous performance boost. We've seen more than 20% performance improvement running on standard CPU architecture. So highly efficient on CPUs, supporting low latency retrieval. And on the right side, you have the tools. Tools are what power your agents to get some action done. Again, in RAM, you can actually isolate tools. They can run in their own containers. And with each of them, you can actually connect specific resource limits. So a very deliberate architecture that's meant to be efficient on your infrastructure. It's meant to isolate workloads and associate specific limits around it. So that's something that we're doing with RAM. And as we're talking about flexibility from a deployment perspective, I wanted to share what the landscape looks like. So as you can see on the left, RAM is supported both on cloud and on-prem. We support AWS and Azure as our cloud providers. We started with general purpose Kubernetes as our on-prem, but earlier this year we launched support for Red Hat OpenShift. So those are the platforms supported from a deployment perspective. From a dependencies, we need a standard Kubernetes cluster, and we need a Postgres SQL database. If you look at the LLM endpoints, when you're running in cloud, you can bring your own LLM, your choice of LLM, depending on what that cloud provider provides, so whether that's through Foundry or Bedrock. We also can run on-prem LLM, so these smaller models that can be hosted on-prem. So we have support for both Ollama and VLLM. And just to round it out, on the bottom right, these are the vector databases that we have native support for. So if you're running Postgres, it's really easy to turn on the PG vector extension of it. That becomes your vector storage. But we also have first-party integration with VV8. They are a native vector storage company. So that's the landscape from a deployment and dependency perspective that we're looking at. So with that, I pass it back to Achita to talk about the CPU and GPU balance here.
Thank you, sir. As we mentioned, it's a fine balance of CPU and GPU. As you all know, GPUs are expensive, hard to get as well. So when you are looking at your workload, please look into it and make sure that your workload, you are optimizing your hardware as best as you can. So wherever it is not necessary to invest or utilize the expensive hardware, there are CPU options available with the AI accelerator. So majority of your AI pipeline nowadays, you can use CPU and use CPU most efficiently with our latest and greatest, so that you can take advantage of the AI capability that it has, and it is not very heavy on your pocket as well. So with that, I will quickly mention that with SAS and Intel collaboration, this Retrieval Agentic Manager is fully equipped to support purely on CPU whenever applicable, of course, if the LLMs are not too big. And it is overall very efficient as well as lower. It will help you with the cost as well.
Thank you, Achita. So with that, we have reached towards the end of our content. So let's summarize with a few key takeaways. So as we talked about, AI systems are pipelines, not single models. So it's important to look at it from that perspective. Takeaway number 2, I think, is the most important thing in this presentation. Heterogeneous workloads, they're not identical. And heterogeneous workloads require mixed compute strategy. As Achita talked about, CPU-first optimization reduces cost, and in most cases, without sacrificing performance. And this is the area where we are innovating together. So together, SAS and Intel enable scalable, enterprise-ready agentic AI. So with that, that's our content. This is our contact information. If any of you are interested in it, if you have more interest in agentic AI pipelines, I am actually doing a session at 5 p.m. today, which is just opening up the agent, the anatomy of an enterprise agent, taking a more functional lens at it. We also have content at the Intel booth and Agentic AI booth where we are showcasing some of these in action. So please visit us there.
Thank you, Arvind.